Hello everybody, my name is Jeremiah Flores, and I'm currently a student at Full Sail University. And I'm recording this video today for my class PNP4. Let's get started. The last time I recorded a video, it was for Tic-Tac-Toe and the functionality behind it, how you built it up in Unity. Well, this time instead of Tic-Tac-Toe, I'm making a basic NPC based off of an animal. And the animal I chose for this is the Gila monster. And for those who don't know the Gila monster, it's a venomous reptile that's rather lethargic, so it's inactive and relatively slow half the time. And fun fact, when provoked, it injects a mild neurotoxin into its enemy by biting them. But anyways, this NPC is set up just for simple movement and tracking and everything. I want it to basically mimic the Gila monster, and I'll pull this up here. This is Trello. And basically what Trello is used here in this scenario is everything I want to achieve throughout this process. So as you can see here, character movement based on time, set timer for character, add movement function through vectors, allow the NPC to eat, which will be this, enable the AI to move after eating, because beforehand it was kind of just stopping right where it was, and so on and so forth. Anyways, let's get back to this real quick. And as you can see, the little cube that represents our food, it's nothing really special. The only thing that's special about it is that it has a box collider and it's marked as a trigger, as you can see here. And I'll give a little demonstration. So as you can see, as previously stated, they are slow, but it instantly tries to track it no matter where you move it until it gets it. And once you get it, you see that the wandering bull here is set to true. And in that case, you'll look down here. It's just kind of moving freely wherever it wants to. So go into the code here, and before I go any further, I would like to thank my professor, Mr. Acosta. Some of the coding he provided for us in class was utilized in this and was used to form a bit of a foundation. I would also like to thank him for helping me with a few of the problems I encountered during this process. I would also like to thank my classmate, Lloyd Jarrell. He pointed out a few of the ways I was able to simplify my coding and make it more manageable and efficient. And finally, I would like to thank my other classmate, Carson Hawley, for helping me through my trial and error process on what you can classify as my state machine and trying to make it work properly. Now, as you can see here, there are a few private variables, which means nobody has access to these except the objects it's attached to and its children. And the serialized field makes it so we are able to edit it in the inspector. We also have a game object variable and everything that allows, in this case, is allowed to the NPC to track the food and eat it. And scroll down here into the void start function real quick. The food is set active to true, so it's just in the scene. And then timer equals time.delta time, meaning the timer is equal to the amount of time it took to complete the last frame. And timer length is equal to timer. Timer start is equal to 0, same as timer move. And we also call the rigid body component in here as well, because if we don't, the NPC won't move at all. And then wandering, the bool that's right up here, is set to false. And in void update, if wandering is set to false, we call all of this right here. So we call the distance function, so let's take a look at that real quick. Max distance equals vector3.distance, food transform.position, transform.position. And what vector3.distance is doing here is that it's getting the distance between them. It's returning the distance between vector A and vector B. So in this case, the food's position and then the Gila monster's position. So that's what's being called back up here. Timer plus equal time.delta time, which as previously stated is the amount of time it took in seconds to complete the last frame. And then timer length is equal to timer once more. And then we also call the movement function, which scroll right down, and it's right below the void distance function. If timer length is greater than timer start, which it always should be, the rigid body velocity, so the vector velocity for the rigid body is equal to transform.forward times 3. So that's being called back up here as well. And then transform.lookAt food transform, which you can read this as Gila monster is looking at the food, because we're getting the Gila monster's transform. The look at is changing the rotation of the Gila monster for it to look at the target, which in this case is the food's transform, which we establish right up here. Then, if the food in the hierarchy is equal to false, we call the wandering bool is set to true. And then wandering state is called the wandering state function, which is right down here. Which, looking at this now, it's a little redundant to have both of these here. But time remove is plus equal time dot delta time. And then if time remove is greater than or equal to timer direction, which we can see right where timer direction is used, and it's not used in anything except where it's established, which it's equal to 3. So the time remove is greater than or equal to 3. Then transform dot position is equal to vector3 dot lerp, and just in case, I'll pull this up. Here we go. So vector3 dot lerp. Here's some of the information behind it. Long story short, it returns the midway point between A and B when it gets A, B, and C in this case. So right down here you have vector A, vector B, and vector, well, not vector C, but the midpoint. And then you also have transform dot rotation equals quaternion dot look rotation to random direction, which random direction is being defined here. It equals a new vector 3 x-axis transform position dot y z-axis, and what this is doing, as you can see here, x-axis and z-axis are equal to random range -90 to 90, meaning every few seconds a random point is being decided for both the x-axis and the z-axis, and it can range anywhere between -90 to 90. And then transform dot position dot y is basically just, it's the y for the transform on the Gila monster. So that is not going to be messed with whatsoever. We don't need a flying Gila monster on our hands. And then time remove is equal to 0, just in case we want to set this back to 0 every now and then, because if we don't, our Gila monster is basically going to be going everywhere, and I will demonstrate it here real quick. So, since wandering is called after the wandering bool is set to true, we just need to wait for him to eat the food. It'll go on for another second or two, and then once the change hits, there it is. Look at him go. So let's go back and fix that. And right back in here. That's all being called here. Once again, movement is being called, which is the rigid body velocity equals transform dot forward dot times 3. And then just for the food disappearing and everything, it's a void on trigger enter collide or other. If the game object dot tag is equal to Gila monster, which our Gila monster is tagged as Gila monster, once it collides with it or enters the trigger of it, the food is set active to false, wandering is set to true, which allows this to take place. And that's all there really is that's needed to know about the coding. So now we'll view a little bit of the documentation behind it. It's relatively simplistic and everything. So for the item that was used in this, it's just called food. The behavior of it, it's a stationary. The owner of it, in this case, wasn't sure how to interpret it. In this case, it would be Gila monster. The location, again, stationary. It's just staying in a singular spot at the entire time. There is no major information to it. It's an object, just a regular 3D object, visual 3D. Geometry, it's a cube. And general data, this is calling for the NPC. This is the speed of it. And stationary, that's the seeing distance of it, so it's just like getting it from here to there. And interaction, the only thing that can interact with it is the Gila monster and some of the attribute descriptions for it. Like I said, there's no really any value ranges to it. All the value ranges are applied on the Gila monster itself. And once they eat it, the event triggers, well, it's eaten and the Gila monster wanders around, which is calling the wandering state. Let's see. I don't believe there's anything else I need to cover. This should be all of it. I hope you all have a wonderful day. Thank you for watching this video. Hope you enjoyed.